were the days of Elijah.
Welcome to another mathematics video tutorial, another CDP Maths Lab Teaching and Learning Center production, brought to you by Ronique Bernard. Instructions. This lesson was not designed for entertainment. It was designed to be interactive, so therefore, we're asking you to follow each instruction given to you by the tutor. If not, this video will be very useless to you and boring, so please follow each instruction. Remember to do all the tried questions before starting your worksheet. Our topic for today is computation, lesson number 1. Content of this lesson: naming fractions, types of fractions, addition of fractions, subtraction of fractions, multiplication of fractions, division of fractions. Okay, now we're going to start off with what? Naming fractions. Now, you can tell me how much circle do I have here and how many rectangles do I have there? Did I hear one? Good. Now this circle is representing one whole circle, and this rectangle is also representing one whole rectangle. Now, one whole can be equal to the total amount of pieces, total amount of persons, total amount of money, total amount of anything. And of course, we could use another word, what? Sum. Alright, now pay close attention to what we're going to be doing with these shapes. Question: what did I just do a while ago? Yes, I divided the circle into two. Okay. Did I do the same thing for the rectangle? Yes, I did. I divided the rectangle into what? Two. So how many parts do I have here? I have two parts and two parts here too. What did I do this time? Yes, I divided the same circle into what? One, two, three, four different parts. And the same for the rectangle. One, two, three, four. No, what did I do this time? Okay, I divided the circle into one, two, three, four, five, six, seven, 8 parts. And the same for the rectangle. One, two, three, four, five, six, seven, 8. So we have just divided this circle into 8 parts and this rectangle into 8 parts. Now, so the whole circle was divided into what? 8 parts. The whole rectangle was also divided into 8 parts. So the total number of parts in this circle would give about the what? Whole. And the total number of parts in this rectangle will give you about the whole. Very good. So we're going to name each part. Now, let's test yourself. How many parts is shaded in red of this circle? Okay. Now, how did you get your answer? Did you count the number of parts first? Okay, maybe you should. Now, what's a denominator? Now, a denominator, so this tells how many pieces the whole was divided into. So let's look at this now. This whole is divided into how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. So we're going to write the denominator right here. Okay, so the denominator tells how many pieces the whole was divided into. So this whole was also divided into 8 pieces. Now the numerator, if you look at the arrow, the numerator will be the top number. Now the numerator does what? This tells how many pieces out of the total number of pieces that is shaded for the example. 1 out of 8 pieces. So I've shaded 1 out of 8 pieces. So the name of that piece is 1/8. Very good. Now let's look at what is this again? How many circle? Good, 1/8. Now question. What part of this circle have I shaded in red? Did you say what's the denominator? 1, 2, 3. And what's the numerator? 1. So what's the name of that fraction? 1/3. Good. And here we go. For the rectangle, it's the same 1/3. So 1, 2, 3. But I'm touching 1/3. What have I done to this circle now? I've also divided into what? 1, 2, 3, 4, 5, 6 pieces. Question. And the same for the rectangle. Now what's the question here? What's the name of this piece that I've shaded? You can pause the video and give me the answer right there. So follow my instruction. Pause the video and then name this piece. Let's see. Did you count the number of pieces? 1, 2, 3, 4, 5, 6. So 6 pieces. And how many pieces out of 6 is shaded? 1. So the name of that piece is 1/6. And note, if I had shaded this one, it would have still be 1/6, 1/6, 1/6, 1/6, 1/6. Very good. And it's 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. So these are all 1/6. Very good. Now try this question. Draw a diagram to represent 1/5, which is 1 out of 5 parts. You may use a rectangle shape diagram. So now pause your video and draw this diagram. So you'd first draw your rectangle. Did you do that? Then you're going to divide it into how many pieces? 5 pieces. Did you do that? 1, 2, 3, 4, 5. So 1/5, 1/5, 1/5, 1/5, and 1/5. So now I have a diagram showing me what? 1/5. So each piece is 1 out of 5 pieces. Now try this question again. Now draw a diagram to represent 3 out of 5 pieces. You may use a rectangle shape diagram once again. So here it is. It's now divided. 1/5 again. 1/5, 1/5, 1/5, 1/5. Now, you may pause your video right here and continue. Okay. Let's see if you and I have the same answer. Did you shade it? That's 1/5, right? That's another 1/5. Now, how many 1/5s have we shaded? 2. Very good. And our third 1/5. So now we have 3 1/5s shaded. So 1 and 1 and 1. So there are 3 1/5s. Did you get that answer correct? Okay. If you did not, try again and make up a question similar to this and move forward. Okay, very good, easy. Now we're going to look at now types of fractions. Vulgar fraction, equivalent fractions, improper fraction, and mixed fractions. Now, you want to describe the area shaded in red. Now note 1, 2, 3, 4, 5. What's the name of this part? Good, 1/5. This part, 1/5. So each of them is 1/5, and this is one hole. Now, if we were to take this hole and place it along this, you'd notice that it is what? Equal. Okay? 1/5, 1/5, 1/5, 1/5. So now you're going to describe the area shaded in red. That's 1/5, 1/5, and 1/5. So go ahead and describe the area shaded in red. Pause your video and write down your response. Did you get 8/5 or 8/5? No, 8/5 is called an improper fraction because the numerator is greater than the denominator. So whenever you have a fraction where the numerator is greater than the denominator, it's called an improper fraction. Now, if you had written your answer as 1 3/5, then it would have been a mixed fraction. Now, what's a mixed fraction? A mixed fraction is a fraction with a whole number and a vulgar fraction. So here we have a whole number and a vulgar fraction. Now, a vulgar fraction, of course, is where the numerator is smaller than the denominator. Try this question. Describe the area shaded in red. Let's go back again. Take full notes of what's happening there. So we have shaded that, and that, and that. We have shaded that, and we're also shaded that. So go ahead now, pause your video, and describe the area shaded in red. Did you get these answers? The first answer, it is 2 3/7 or 17/7. Now if you did not get these answers, try again until you get these answers. Now try this question once again. Describe the number of sticks circled using fractions. Look carefully, then you describe. So once again, pause your video and try. Did you get these answers? 3/6 or a half? Okay, you might be asking, how is that so? Now if you count each stick, 1, 2, 3, 4, 5, 6. Now how many sticks are circled? 3 out of 6. Or if you realize, we divided these 6 sticks into two different groups, so you get 3 on one side and 3 on the other side. It is 1 out of 2 groups of sticks. Now let's look at another concept in fractions: equivalent fractions. What are equivalent fractions? Now they are saying to us that equivalent fractions have the same value even though they may look different. What do we mean by that? Now, what fraction have I shaded? Look again. What fraction did I shade? Here's a question. What fraction of the rectangle is shaded in red? Did you see a half or 1 out of 2? You'd be correct. Now, tell me now, what fraction is shaded in red here? Okay, I heard you. 1 out of 4, which is a quarter. Now you tell me now. Is this a quarter? Is this a quarter? Here's the question. What fraction of the rectangle is shaded in red? What is your answer? Did you say 2 out of 4? Exactly, 2 out of 4. However, 2 out of 4 is equivalent to a half. Now look carefully what happens. Good, you realize they're the same size? So 2 out of 4 has the same value as a half, but they look different because what? They have different denominators and different numerators. So they look different, but they're the same value. So we're continuing looking at equivalent fractions. Now I want you to look at the screen carefully. Good? Alright, let's go. Now, what did I just do a while ago? Good. What fraction of the rectangle is shaded in red? Okay. Did you say 1/3? Yes. If you count 1, 2, 3. So there are 3 parts, but I shaded only 1 out of 3 parts. Now, what fraction of the rectangle is shaded in red? Did you say 2/6? Yes. Why is it 2/6? Because there's 1, 2, 3, 4, 5, 6 parts, but I shaded 1, 2 out of 6 parts. However, why is it that 1/3 is equivalent to 2/6? Now, if you notice that I can use 2 1/6 to give me 1 1/3. Look, exactly. So I can use 2 1/6 to give me 1 1/3. So therefore, they have the same value, but they look different. Now try this question. Notice what I did. Let's try it again. Pay attention. Very good. Very good. Now here's a question. What fraction of the rectangle is shaded in red? Did you say 2/3? Very good. Now, let's go for the real thing. Now you're going to read this question, then you're going to pause the video and try the question. It says what fraction of rectangle 2, which this is rectangle number 2, must be shaded in red for it to be equivalent to the shaded area of rectangle 1. So pause the video and try this question. Okay, let's see if you and I have the same answer. Did you shade that one? Did you shade that one? Did you shade that one? So your answer is supposed to be what? 4/6. Why is it 4/6? No, this is 1 2/3. And this, as we just looked in the example before, that we can use 2 1/6 to give us 1 1/3. But how many 2/3 we need? 2/3. So we need another set of 2 1/6. But in all, we get 1, 2, 3, 4 1/6. So this should be your answer. So I wanted to stop up for a moment, think about it, and reflect on it. Make up a question similar to this right now before you move on. Very good. If you want to understand, ladies and gentlemen, boys and girls, you need to follow my instruction. So pause the video here now and make up something similar to this. Very good. Let's continue. Try this question number 2. Pay attention. And the same question. What fraction of the rectangle is shaded in red? And of course, you know it's 2/3. But here's a big question. What fraction of rectangle 2 must be shaded in red for it to be equivalent to the shaded area of rectangle number 1? Okay, now, so we need 6/9. Let's see, how much did you shade? 1, 2, 3, 4, 5, and 6. Now, you may be asking, is that equivalent to 2/3? Okay, look, if you place 1/3 on 3/9, you'll realize that it is what? 1/3. So 3/9 will give us what? 1/3, and then the other 3/9, 1, 2, 3, will give us another 1/3. So how many 1/3 would that be? 2 1/3. But however, this fraction, the name of this part is 1/9. Why? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. But how many parts out of the 9 is shaded? So it's 1, 2, 3, 4, 5, 6. So we're seeing that 6/9 and 2/3 have the same value, but they are different. Now we're going to look at addition of fractions. Now listen to the teacher. Add the following fractions: 2/5 plus 1/3. Okay? Now you may pause your video right here and try this question. But if you get the answer wrong, then pay attention and follow as you go along. Okay, now addition of fractions. Now note, this bar represents 1 whole. So this entire bar represents what? 1 whole. Now take the bar and divide it up into 5 parts. So here we are, 1, 2, 3, 4, 5 parts. So 1, 2, 3, 4, 5 parts. 1/5, 1/5, 1/5, 1/5, and 1/5. Now note, the question says you are to add 2/5 plus 1/3. So now note, now take the same bar and divide it up into 3 parts. What are we going to have then? Now note, if you count each part, you'll get what? 1 out of 15. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's not 6 but what? 5. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 3s 15. But one part is 1 out of 15 parts. And how many parts have I shaded here? 3 out of 15 parts. Now you're going to pay attention to the video clip that will come after this. Good. So you have answered this question. What fraction is shaded? And the answer will be 3/15. And let's see what is 3/15 equivalent to. Okay. How many pieces of paper do I have in my hand? Okay. It is one paper. Therefore, it is one whole paper. Now, we are going to use this paper to do what? To add 2/5 to 1/3. Okay, do me a favor. Take a paper like this for yourself so that you can follow me while I fold. Now the first thing I'm going to do, now if you look on in your notebook, you have two fractions. One says 2/5 and the other says 1/3. Now step number one, you can use either the denominators. You can either use the one that has 5 or the other that says what? 1/3. So guess what? I'll use 5. So I'm going to take this whole and I'm going to divide it into what? 5 different pieces. I'm going to fold my paper into 5. That's 1. And that's 2. And remember that it must be even. Alright? That's 3. That is now what? 4. So here we have, when you open this out, you'll be able to count 5. See them? That is 1, 2, 3, 4, and 5. So here we have 5 different parts. Good? So each part is called 1 out of 5. So this is 1/5. This is 1 out of 5, 1 out of 5, 1 out of 5, and 1 out of 5. So each part is called 1 out of 5 or 1/5. Okay. Now, so now we have found 1/5. Now can we identify 2/5? Let us look. This is 1/5 and another 1/5. How many 1/5s do I have there now? 1, 2. Good. So this is 2 1/5. So this is 2/5. Very good. Now, the other question is now, how do we get thirds into this? Alright, what am I going to do now? I'm going to take the same paper and I'm going to fold it into 3 different parts. So what we could do is fold it like this again. Like that. This is still 1/5, don't it? Still 1/5. So I'm going to divide this 1/5 into 3 different parts. Alright. So if I can do it another way like this, just to make sure it's done accurately. Okay, so here am I. I'm going to fold it neatly. That's 1. And that is 2. So, how many pieces am I going to have now? So here I have. Now you're going to tell me where the third is. So look at it. See the crease coming down? Good. So we have 1, 2, 3. Realize that? So this is 1/3, another 1/3, another 1/3. So here we have 1/3, and we have 1/5. But what did you notice? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 different what? Pieces. So each piece then is called what? 1 out of 15. It is no longer 1 out of 5. It's no longer 1 out of 3. So it is now 1 out of 15. But we can find 1/5 and 1/3 dividing up the 15 different parts. Okay, I'm going to now paste this to the wall and do some other exercise with you. So follow me now. I have just taped my paper on my wall. You could have done the same thing too. Now what you have noticed that now I have highlighted the creases that I'm seeing in the paper using my black marker. Okay, so as you can see, we have 1, 2, 3, 4, 5. So this is what fraction? Good. 1 out of 5, which is 1/5. What is this fraction to? Good. 1 out of 5, which is 1/5. So all of them are called 1/5. Well, the question is then, where is the 2/5 again? This is 1/5. This is another 1/5. So 1/5 plus 1/5 is equal to 2/5. Okay. Now we need 1/3 now. I'm going to use this. Here is a crease. Can you see the crease along here? That's 1 crease, 2 crease. Let us see our 1/3 now. Okay. Can you see the 1/3? Look at it now. So we can see 1/3, which is 1, 2, and 3. That is 1/3. So we have 1/3, another 1/3, another 1/3. Well, the question is then, what fraction is this piece? Okay, I heard you. It is 1 out of 15. Good. So each piece is 1 out of 15. Now, question. How many 1 out of 15s make 1/3? Okay, I heard you. So we count 1, 2, 3, 4, 5. So you write that down. So 5 1/15ths make 1/3. See? 1, 2, 3, 4, 5. Another 5 1/15ths give us another 1/3. 1, 2, 3, 4, 5. Another 5 1/15ths give us another 1/3. Okay, next question. So you could write that down to the side. The next question then. How many 1/15ths give us 1/5? So let's look at it. This is 1/5, 1/5, 1/5, 1/5, 1/5. So the question once again, how many 1/15ths give us 1/5? So we could write another 1/15th here, another 1/15th here, and how many? So we have 1, 2, 3 1/15ths will give us what? 1/5. So 5 1/15ths is 1/3, and 3 1/15ths is 1/5. Okay, let's record some data here. Now we're saying that 1, 2, 3 15ths is equal to 1/5. See? 1, 2, 3, 4, 5. So it's equal to 1/5. Good. So we are saying now that 1, 2, 3, 4, 5 15ths is equal to what? What is it equal to? Alright, let's look. This is 1/3. See? Another 1/3, another 1/3. But how many 1/15ths make up that 1/3? Okay, so it is 1, 2, 3, 4, 5. So the 5 15ths is equal to 1/3. However, what are we adding? We will be adding 2/5 plus 1/3. So if 1/5 is 3 15ths, then how many 15ths will give me 2/5? Okay, let's see if you're correct. So this is 1/5. This is another 1/5. So how many 1/5 do I have here now? How many 1/5? So this is 1, 2. So 1, 2, 3,